I am Patrick Mannion, Director of Content at Claritech, and we're here at the Louisville, Colorado facilities of Kyrio Inc. to look inside the insanely complex world of wireless systems test. So what is Kyrio's focus, Mitch?
You know, Kyrio is all about working with companies whose customers are about connecting people, places, and devices. And we are really the trusted resource, trusted and secure resource for innovation coming out of the labs.
Right.
So we do all kinds of things like security of devices and networks. We also create online marketplaces so that transactions can occur for helping broadband and wireless growth. We also do a lot of work around testing.
What kind of devices do you test for?
We test all kinds of devices. I mean, if it's connected to a network, it's possible we might have tested it already. So it can be handheld devices like cell phones, it can be access points. We also test non-wireless devices, fiber-based, coax-based, et cetera. And we'll do everything from looking at housing, antenna designs, all kinds of capabilities that can affect the performance of the device, especially in the wireless world.
Now, clearly, in the space of wireless, there's lots of innovation happening, right, and lots of challenges that go along with that. How is Kyrio addressing that?
Well, we take a very in-depth look at what the characteristics of the device and what the performance of the device is. One of the companies that we work with, as you can see, kind of the lab behind us goes way back to the end of the building. We have all kinds of test equipment in our facilities. And one of the companies that we work with is octoScope, octoBox. That they provide to help us with really characterizing what the performance of the device is under different test conditions. And we can do that with previous generations of technology as well as what kind of the latest things that are coming out like MU-MIMO.
So what does octoBox bring, and why did you invest in that particular piece of equipment?
Well, it's a nice compact footprint that we can do multiple things in a variety of testing with. So we can put an access point in it, we can put an end user station, a device in it and test it. And we can do just the basic things of everyday Wi-Fi usage, which can also push the boundaries of things like MU-MIMO and really understand what the performance characteristics of it is, because the specs on a device are really just the starting point. It's how does it perform in the field, and this gives us an extremely accurate picture of what that looks like.
The wireless products we use every day deliver high-resolution video content and are capable of real-time video calling, gaming, and other bandwidth-hungry multimedia applications. All these demanding applications work thanks to the thorough and elaborate testing that enables engineers to optimize the wireless devices and networks. Now, we all know it's hard, so let's talk to Wiley Nelson, VP of Wireless and Testing here at the Kyrio facility in the lab. So let's go see him right now and see how it's done by the real experts. Hey, Wiley.
Oh, hey, Patrick.
Hey, good to meet you. Good to see you again. Okay. So can you give us a quick rundown of what it is that Kyrio does?
Well, we do a lot of different things, but one of the things I was just doing was some wireless testing with our octoBox system.
What's the octoBox? Can you explain how that works?
octoBox is one of the tools that we use to do extensive wireless testing, which is one of the services that we offer here at Kyrio.
Right. What do you find are some of the major challenges you're facing when it comes to wireless tests?
Oh man, that list is almost endless at this point in time. As wireless systems get more and more complex, the amount of testing that you have to do to understand what the quality of the device is goes up exponentially.
Right.
So we utilize a lot of tools. One of the things I like about this system is that it's quick and easy right out of the box. You've got a whole set of wireless testing capabilities that you can deploy and start working with.
So can you explain some of the ins and outs of what you have here on top?
Yeah, absolutely. So we have several PAL devices. We can simulate multiple different clients. We can simulate multiple different access points. We can simulate several different types of interference, which is, again, kind of one of the reasons we're able to test a lot of different functionality of a device very quickly and very easily configured in this box. The other thing we can do is we can simulate, because we have two chambers, we can actually simulate handover. So Wi-Fi to Wi-Fi or Wi-Fi to LTE. In an environment where you're going to get repeatable results.
I guess maybe too how two similar devices might interoperate.
Yeah, absolutely.
So how's it controlled?
So it's controlled on our software system over here, which I was just working on. Okay. And so as you look through this, you can see there's a lot of different inputs that you can put in. Basically, select your test. How long do you want it to run? What level of attenuation do you want to do? One thing I didn't show you when I had the door open was that the thing actually rotates, so you get a turntable in there.
That's important.
And so you can actually figure out if the device you're testing has any directionality. So how fast you want it to rotate, how many different data points you want to collect per rotation, which is very nice because, again, kind of to the economics of what your customer wants, you could take a test measurement every degree of rotation if you wanted,
Right.
or you could do it every 30. Obviously, one takes longer and costs more, but if they want that level of detail, you can provide that for them.
You can set it to any kind of resolution that you want, really, and then maybe leave it for a day or two.
Yeah, that's right. It's a very flexible device and allows us to kind of select whatever we want in that set of kind of inputs or variables we're looking to test.
Can you explain how it works then?
Absolutely.
Maybe walk us through one of your tests that you're currently doing.
Yeah. So I was just running a throughput versus time test.
Okay.
So the octoBox is a semi-anechoic chamber, and we actually have 2 semi-anechoic chambers. You put your device under test. Right now we're testing an access point. We have several configurable antennas. We can kind of position them as we want. Right now we have them all along one side.
Right.
And basically we're increasing the attenuation to try and demonstrate how does the device perform as time passes and you get a less and less strength of signal, basically.
Interference as well from outside coming in as well, right?
Yeah, that's another great thing about this. We can test a lot of different characteristics very quickly, right? One of the things that we struggle, and I think the entire wireless testing world struggles with, is with these complex systems, you could literally spend almost an unlimited amount of time and money testing it.
Right.
So how do you get to actionable intelligence and really good results that your customers can then utilize quickly and economically? And a device that allows you to do a lot of different things becomes very powerful in your arsenal of tools to use. So
the better you can do it, well then I guess the better you can supply the answer to your customers too.
that's right. The faster and less expensive we can supply that answer to the customer, which they like a lot.
So now we're getting a look at how to get a good characterization of throughput versus range versus orientation for a given device, in this case a wireless access point. So here we set up 2 endpoints for an iPerf throughput test. We configure the test to step through programmable attenuation ranges as the device rotates. Here we are stepping through 3 attenuation levels at each orientation point. The levels are from 20 to 40 dB in 10 dB increments. The initial measurements for the 3 levels are then taken. The dwell time is 15 seconds with a 2-second delay after stopping. Then the device rotates another 30 degrees, and the measurements are repeated. To test the full 360 degrees will take 10 minutes, so we'll accelerate it with some video magic. So here we have a good characterization of throughput versus range versus orientation for the device.
For our next presentation, we are going to demonstrate how we are doing roaming testing using the Octo systems. The screen is going to show you, this PowerPoint shows you how is the whole system configured. So we are going to emulate the movement of somebody from one access point to the next one. So you can see in this part of the screen how the energy from the first access point is going to decrease, while the second one is going to increase. These are actually pings results of the system pinging the station, and as you can see there is a little gap of time where you actually have to do the actual roaming. So the transition is as expected, right, from a fully pair from a full pair device into one of the access points. Is going to move and it's going to disassociate with that one and it's going to associate with the next one. All this is happening inside of the box, and it has no other component than actually the Octo systems. So with that, I'm going to start an actual run from the box and going here. So you click on your roaming operations. So this is where you control the parameters. We do have a time ramp up. So this is actually the parameter that defines how long is going to be the process. This is in milliseconds. So right now it's set to happen. Everything will happen on 5 seconds. So let's transfer the device. And we click here, and the actual transfer starts happening. The test is actually going on. It takes some seconds before, some seconds after, 5 seconds during the actual transition, and voila, we get results. So again, you can see real data here, how the ping was the device answering to the first connection. Then you have the transition gap, and now it's answering again, but in the second access point.
So tell me, what else did you like about it?
I mean, we like almost everything about it, right? They've done so much. They've thought about everything from having a bench on the side where you can actually set your laptop down when you're working on it, to putting it on wheels and making it modular. What I think we like most about this tool is that it really is something that any company or any group that is serious about having high performance wirelessly connected devices should either have one of these or they should work with a test house like Kyrio. And it's a completely isolated test bed where you can control the impairments, do a wide variety of testing, things like throughput, time, attenuation, rate versus range, etc.
All main things of that nature.
Yeah,
right? Yeah.
that's right.
Very good. Okay. Thanks, Wiley.
Yeah.
Good job. Appreciate it.